All right, welcome back to GD50. This is lecture 8. Today we're going to be diving into the world of Unity for the first time, which I'm excited about. Going to be kind of a whirlwind tour, but we'll try to cover as much as possible. Transitioning away from 2D and away from Lua and LÖVE 2D into 3D and C# in the context of Unity. So today we'll be talking about Helicopter Game 3D. So a Helicopter Game is a 2D game that was really famous in the 2000s. It was a web game. It was sponsored on a bunch of websites. Addictinggames.com still has it on there, and a few other websites have it. It was a Flash game, but I remember playing it a lot. It was the old precursor to Flappy Bird, which was mentioned on the Wikipedia page. There's a reference to it there. And this is sort of what the gameplay looked like. It was very similar to Flappy Bird, a little bit different in that instead of trying to avoid pipes, you're in a cave and you're trying to avoid the ceiling and the bottom, the ground of the level. And there were these little obstacles that would spawn in the middle as well, so you'd have to navigate that. But it was the same exact mechanic, the sort of like click to go up, and then when you didn't click, your helicopter would just sort of sink down via gravity. Today we'll be talking about a bunch of brand new topics, things like Unity, first and foremost, the sort of ecosystem with which we'll be doing a lot of the things we'll be doing. C# is the primary language we'll be using, so we're going to take a step away from dynamic languages and move towards statically typed languages, languages like C# and Java and the like. Blender is a program we'll look at briefly today just because in the context of 3D development, you're going to want to have a tool that will let you create models, and so the 3D software that I like to advocate for the most, especially for folks that are just starting out, is Blender because it's free and open source and it has much the same feature set as any commercial software like 3D Studio Max and Cinema 4D and the like. We'll talk about what components are, entities and components, how they relate in this model that Unity has adopted for all of its programming. Components are little pieces of behavior that you can then sort of combine to form a whole that will then drive the behavior of whatever object in your scene you want, rather than having to customize its behavior via a long chain of inheritance and instantiation. Colliders and triggers are important in 3D and 2D, but today we'll be talking about colliders and triggers, things like the helicopter colliding with coins and buildings and other planes that are flying. Each of those has to have a collider, and certain things have to be considered triggers in order to trigger certain behavior with other entities. Prefabs and spawning. So prefabs is a huge concept in Unity. So prefabs are basically prefabricated objects that you can customize as you want to, lay them out in the editor rather than having to necessarily code all of the details. And then you can instantiate them in the actual scene via code programmatically in a way that fits the model you're striving for. Texture scrolling is something we'll look at briefly because it's the way that we accomplish the infinite sort of scrolling aesthetic or behavior. And we'll look at how we can do that in a different way than we've done before using UV coordinates and specifically looking at materials and modifying certain attributes of those materials. And lastly, to tie everything together as we've done before, we'll look at audio, things like audio listeners and audio sources, what the differences between them and how to add them easily to our game project. But first, a demo if there would be anybody willing to come up and take a look and play the 3D helicopter game that I put together. It'd be awesome. Anybody? Steven? Awesome. Thank you so much. Let me go ahead and actually get it. So I've pre-built it. So let me go ahead and... So the nice thing about Unity is it exports to multiple platforms, and right out of the gate you can get just a, I didn't put an icon for it, but you can create just a native application very easily. And so whenever you're ready, go ahead and hit play, and up and down will move your helicopter. So this is the 3D helicopter game, and I don't think we have sound live, but there should be audio. Oh, I might have actually. Here we go. There we go. That's my bad. So there's music playing. There's sound effects. So notice that we have a 3D model. This is what's called a 2.5D game. So even though everything is in 3D, the models and so forth, the actual axes upon which we're bound are just two. We're just bound to I believe the X and the Y. It could be the Z and the X. I don't recall offhand. But we're bound to just simply two axes of movement. But all the models, as we can see via the camera, are in 3D, including our helicopter. So we have a few things going on. We have skyscrapers that are scrolling by. We have coins that are also going by at the same speed as the skyscrapers. We have a background that is infinitely scrolling. We have, of course, our helicopter, which has a rotating set of blades. And when we collide with a coin, notice that we get a little, it might be hard to see in-house, but we have a little particle effect that plays. there's airplanes that are flying up top, so we're instantiating those as well to fly past us to provide another layer of obstacle. And if we collide with an airplane, notice that we get despawned, and then we trigger another particle effect to imitate an explosion. And then notice we also have a couple of other elements. We have two GUI elements, a sort of coin total at the top right, and then a game over bit here in the middle of the screen, which only shows up once we have died. And the explosive behavior, if you want to collide with a building, you'll see that it also triggers when you collide with a building. So there's two things looking for these explosions: the airplanes up top and the buildings below. Those are our two obstacles. But when we collide with the coins, we should increment our coin total and then display a different particle effect. And then this goes on ad infinitum. You can press space to restart, so we have keyboard input that's based on what we press, different things happen. And so that's effectively the demo that I put together today. So thanks, Stephen. I appreciate you coming to demo it. So that's the 3D helicopter game. It's got most of the same mechanics as the web version from before. I would say maybe even more features, just to illustrate a few new concepts. But that's effectively what we're going with today. We're just a pretty simple Flappy Bird-esque, differently themed game based on the same principles. Fly forever, avoid obstacles, and in this case, even get little collectibles. And so notice that there are also effectively two states in our game, which are just the playing state and then the game over state. The two are almost effectively the same. The only real difference is that one doesn't have the helicopter present and displays a different GUI element in the middle of the screen. If you haven't downloaded Unity already, there's two links here. So the top link is just the sort of catch-all download link, and then the second link is the beta link. So we're actually using the beta in this course because Unity has started transitioning away from a numerical system for their releases and is now going yearly with their releases. So the last long-term release candidate was 2017's version, but now that we're almost halfway through 2018, the newest beta is the 2018 version. It has a bunch of new features. So go ahead and check that out. And everything's been well tested and runs very well, very smoothly on Windows and Mac with the new beta. So what is Unity? So the difference between what we've done so far and what we're doing today is now we're actually using a full-fledged sort of game engine, this system. It's got a built-in editor and all this awesome, cool functionality that we really didn't get with LÖVE before. What we were doing before was using a framework and just implementing everything purely in code. And as we'll see today, everything that you want to do that's customizable effectively is or can be done via code, but there are a lot of more efficient and more user-friendly ways to accomplish the same thing, which we'll take a look at. So Unity has a tremendous market share right now. I think in 2016 it had like 43% of all games released were done in Unity. I don't know what the current numbers are. I couldn't find them. But there are other engines that are also very well used, Unreal being among them. And Unreal actually may have more market share now because of games like Fortnite and because it's been improved a lot over the last couple of years and really marketed well. But Go.CryEngine, there are a lot of game engines that are similar to this that provide you this all-encompassing sort of way of dealing with your game scene and with all your game data. But Unity is a very easy engine to start getting used to and cranking things out and being productive with without the tremendous learning curve that some of the other engines like Unreal might have. Unreal does have a more user-friendly way of doing things, but if you want to get down into the nitty-gritty with Unreal, you're coding in kind of semi-arcane C++. So for folks who aren't used to it and used to 3D game development, it can be kind of a large board to get onto. The nice thing about Unity, aside from the fact that it's fairly easy to get started with, is that it's free. And you can use it completely with all of its features until you start making over $100,000 in gross revenue using or releasing Unity products. And then there are other tiers. The next tier above that is if you start making $200,000 and you get new features with these other tiers. But if you want to just start up a new company and use Unity and take something to market, completely free to do so. And once you get over $100,000, it's a good problem to have. It's not necessarily too much to ask to start paying Unity to use it as the means of getting onto the market in the first place. And especially in mobile and VR, Unity is sort of like the forefront. It's got even higher percentage. I think it's like 60-something or 70% market share on mobile. And then VR, from the beginning, it's been it's marketed itself very strong towards the use of VR, and we'll actually use VR in the next lecture. And the way at which we will accomplish all of the programmatic aspect of this, getting things actually implemented in code, is via C#, which is very different than what we've used so far, which we've used Lua, which is a dynamic scripting language, very much like JavaScript. We'll actually be using, so C# is very similar to Java, in which things actually have types. And so here's a couple of screenshots of what the Unity editor looks like. So the nice thing about the Unity editor, actually, which we can see right off the gate here, is that it's very customizable. So on the top, that's sort of the default view. You know, you have a bottom panel that shows you all your resources, all your assets, things like scripts and shaders and models and textures and sounds. You have a nice file browser there on the left-hand side, which allows you to easily navigate your project. You don't have to go looking through your Windows or Mac computer, you know, using your Finder or whatnot, or your File Explorer, and actually look through all your files. You get a nice view there so that you stay integrated within the Unity ecosystem right there. On the right-hand side, you can see all the behavior for whatever objects you might have in your scene. You get a nice big scene view, so rather than having to run your game live and look at the behavior that way, you can actually see in advance what your scene looks like and analyze your game objects that way, and their appearances and whatever you want to do with them, and lay them out perfectly rather than have to programmatically figure things out. And on the left-hand side there, you can see a full list of all the game objects. And then on the bottom right screenshot, you can see that the editor is heavily customizable. So you can lay things out however you want to fit your style of development. I often like to have a panel on top, which shows me my scene view, but then have a panel right below that that shows me the game view. So that if I'm actually running a game and seeing it happen live, I can also see it in the scene and sort of rotate around in sort of this God mode that you can get in a lot of games, and actually analyze and see things that way, and analyze their behavior frame by frame, even if I want to, in a way that's not possible with however I might have coded the camera in the actual game itself. So C#. So has anybody in here used a static language or is familiar with statically typed languages versus dynamically typed languages? Tony, Steven, okay. So what languages have you guys used, just out of curiosity? Steven? Java, C, C++, Tony? C, C++. Okay, so this, to you guys, this will be it's pretty similar. So C# is very similar to Java. It almost looks identical at first glance. There are some features that are different, but it's sort of Microsoft's initiative to sort of compete with Java. It's a Microsoft language first and foremost, but there are ways to run C# code on other platforms, primarily with the use of what's called Mono. So Mono is an open source implementation of what's called the CLR, the Common Language Runtime, which is how Microsoft allows several of its languages like F# and C# and Visual C++, Visual Basic, they all sort of compile to this intermediary format, like how Java compiles to bytecode. And you can run any of those languages' code, their version of the bytecode, with the CLR. And that what Mono is, and what Unity sort of relies on to allow its use across multiple operating systems, is a CLR that's not just Windows specific. It actually runs on Mac and on Linux machines as well. And you'll actually see evidence of its existence via the nomenclature used for MonoBehaviour. So within Unity, there's this thing called a MonoBehaviour, which we'll take a look at. From the beginning, actually, Unity was developed for Mac platforms exclusively, but in 2012 or 2011, they ended up making it usable across all major desktop operating systems. But C#, suffice to say, very similar to Java. We'll look at its syntax, but it's different from Lua in that with Lua, you could just say, x equals 10, or object equals, and then create a table with whatever you want. C# is a lot less flexible in this sense, in that you have to actually tell it in advance what each data type is that you're trying to make. So you can't just create a table or a integer. You actually have to say int, my int, or x equals, and then 10, and then semicolon. So there's also more syntax to be conscious of. And so really quickly, I can show you just what some C# looks like. We'll take a look at this again going forward. But as you can see here, we have public. So that's another thing about C# and Java. If you're familiar with Java, they're object-oriented programming languages. And as such, there are objects that are public and private, and you have access specifiers for different variables and classes that'll tell other variables and classes whether or not they can communicate effectively. So public class just means effectively anybody can see this class. Other classes can see this. But then you have, let's see if I have one of these that has a private variable. I know there's at least one. Here we go. So private text here, for example. So first of all, notice that these are variable declarations like we've seen before. We're saying this is a variable that I'm going to use. In this case, public game object helicopter. So I'm just defining it, I'm declaring it. I'm not defining it. It doesn't equal anything yet, but I'm saying this is going to exist, right? You can say equals something and then define it on the same line. But in this case, we are just declaring in advance what different variables we're going to need later on when we, like for example here we see in our start method, and we'll go over what all these methods are and how they're relevant. But we can see here text equals, and then we're calling some function called getComponent, and then we have some funky syntax here, less than, text, greater than, and then function call syntax, 2 parentheses. So we can see that there's a lot more syntax, but all of the same principles still hold true. It's still much the same way to think about programming. It's just there's a little bit more to stay conscious of. And we sort of trade off this dynamism for more performance. So that's ultimately what it comes down to. Static versus dynamic languages, you're trading flexibility for performance in this case. The C# obviously is a lot faster than Lua. We can do a lot more with it. And actually, Unity isn't itself programmed in C#. Unity itself is programmed in C++. But it allows us to program any behavior that we want to with C#. All right, so that's a look at C#. So we can see also, I was alluding to up here, we have our private, public, and we do things with them. And then depending on sort of what we've declared, public or private, these things also transfer into the editor. We'll see how all of that comes together soon. But suffice to say, that's a look at C#, what it looks like, and we'll use it and we'll get comfortable with it. But it's a little bit different than what we've done thus far. Away from programming, we'll take a very brief look at what Blender is. So I have it installed here. And this isn't required for the course. I will provide you with all the models and all the assets that you need to get working. But this is what Blender is. So Blender is it almost looks at first glance very similar to Unity. It's the only difference, the big difference is this is meant to create new assets. And technically, Blender does have a built-in game engine, but it's not used for that purpose very much. But the sole purpose that we would be using it in this course would be just to create new 3D models. So as you can see here, I can click on these vertices and move them around. And I'm not a guru by any stretch of the imagination when it comes to Blender, but the helicopter and jet and skyscrapers and those kind of simple models, I made all of those in Blender, and those are bundled with the project if you want to take a look at how those are implemented. And you can download Blender at I forget what the exact link is actually. Let's take a look. Blender.org. And then, if you just go down here, download Blender 2.79, looks like the most recent version. Blender 2.8, I guess it's in development, but there's nothing concrete about that on the front page. But yeah, if you want to model 3D assets and you're curious and you want a free piece of really awesome software, can't recommend Blender enough. But like I said, not going to spend too much time on it because that's not it's not something that will actually be required in the course to implement 3D models, to create 3D models, since I'll be providing all of that to you in the project in the GitHub repo. And so here's a screenshot of basically what we just saw. So the fundamental part of Unity. So first of all, let's take a look at the Unity editor. So we can see here much of what we saw in the screenshots, but here I'm live looking at my scene, right? I have a helicopter. I have this background back here. I have a camera that's right here. You can see that it's a camera because it's got the little camera icon, but it's effectively just an invisible game object. It's not actually going to be rendered to the screen ever. And notice that there are no skyscrapers, no coins, no jets, or anything like that. Those are all instantiated dynamically. But this is the beginning of our scene, and it's all laid out in advance. And we can see here with this camera preview, which is kind of hard to see because it's really small. But here's a larger view of what it looks like. And we got a GUI element here. We've got coins here. We have our helicopter. But all of this is sort of how it's a marked difference from what we've gotten used to, which is program everything and sort of load it. And oh, did I put this in the right position? No, I didn't. So I gotta, if I wanted to come over here and just move the helicopter a little bit, which like that. Whoops, I just triggered it. If you click on something, by the way, it will play its any particle systems that are associated with it, so you can actually get a preview for those as well. But I can easily just move it here to the right or to the left before the game actually starts. And if I click on the camera, we can see it there. It's a little bit shifted to the left as opposed to what it was before. But if I just press Command-Z a couple times, take it back to normal. So game object is an important concept. So a game object is basically everything in Unity. So the camera is a game object. The helicopter, which is right here, is a game object. Everything, by the way, that you want to see in your scene in Unity is on this left-hand hierarchy right here. So helicopter, game object. There's got to be a light source in a 3D scene in order for you to actually see things. So directional light, that's a game object. Background, skyscraper spawner, we don't see it anywhere, but that's also a game object. It's just an invisible one. A coin spawner, there's something called a canvas, which if we double click that, we can see we have this obscenely large GUI here that, you know, paradoxically isn't on top of our scene. Unity does a very interesting thing with all of its GUI elements in that it maps it basically maps the canvas to 1 pixel being equal to 1 Unity unit, which is usually equivalent to a meter, and it draws this in a different call, a different draw call than it draws all of the like actual 3D stuff, 3D, all the stuff that's down here basically in world space. So when you create a canvas and you see it's gigantic, that's just Unity's way of doing GUI. It's strange, but apparently they do it for performance reasons because they don't have to calculate like fractional points of where the UI is supposed to be in world space, which can get really small. But the canvas is a game object. Notice that helicopter has children. It's got blades, a body, and then a blades collider, which actually could have been part of just the blades object. Canvas itself has 2 children, coin text and game over, and those are the text on the top right and game over in the center. So those are just two text objects, which are labels that we can just populate with whatever text data we want. The event system is an object that's part of that just gets added to your scene automatically when you add a canvas. Airplane spawner, explosion particles, and explosion sound. So we have all these different objects. They're all part of our scene, and they all do different things, but at the core, they're just game objects. That's the sort of core, like the bottom type. Yes?
So I would imagine you're not actually moving the helicopter or the camera, and you're just going everything else.
Correct.
So can you actually reset the position of the background, first of all?
So the question was, since we are maintaining a consistent position with I'm going to try and scroll in. Here we go. The nice thing about Unity 2 is if you right click, you can use WASD to move around the scene, which is super easy and convenient. But the helicopter here stays in one spot, and the camera always stays in one spot forever. So do we move the text, or do we move the background image like we do in Flappy Bird, in our LÖVE 2D implementation of Flappy Bird, where we reset its position? And the answer is, I will play it right now in scene view and let you decide that for yourself. So let's go to Window. I'm going to go to Layouts. So I like the 2x3, like I said before, so you can see the scene and the game running live at the same time. I'm going to move my camera in the scene so that I'm looking at this kind of from back here. And then I'm going to play the game. And so here's where I'm just going to hold it still. So what do we think is happening? Does it look like that? Does it look like our thing is moving, or is it staying still? It is staying still. Any guesses as to how we're achieving this? Changing the texture. We are scrolling its texture. So when you take a texture and apply it to a 3D surface, you basically tell it where you map the texture coordinates to the 3D coordinates of the object that you want to render. It's called UV mapping. They call it UV because usually when you're dealing with 3D objects, you have your X, Y, Z, and then you want to think of your texture kind of separately from the 3D object, so you use UV instead of X, Y, since you already have X, Y, Z allocated for your 3D object. And so by shifting the, there's an offset part of the texture, the material that holds the texture. There's an offset field that will sort of reposition the UV mapping of that texture onto the 3D surface. And when you offset it, it will just sort of wrap itself around, if that makes any sense. So what we do is I can actually show you in the code where this is. This was going to be mentioned at the end of the lecture, but we have the scrolling background component here, and there's this thing on each material called a texture offset, which basically shifts the UV mapping of your texture to your 3D object. And so by setting that texture offset to some value offset, which is very similar to what we've done before, notice that offset is just scroll speed times time.time. In this case, and I don't mean to overwhelm with necessarily all the details here, but the bigger picture is that we're taking time, the amount of time since the beginning of the game has started, and we have some scroll speed that we've predetermined, and we can just scroll the texture offset here. We're just placing it here at the X. So this new vector 2 offset 0, just think of these two as an X and Y. A vector 2, vector 3. Vectors are just combinations of numbers, so 1, 2, 3, 4, however many you want. A vector 2, offset, and 0. So we don't want to scroll on the Y axis. We just want to scroll it left to right. So we're going to apply no texture offset to our Y axis, but we want to apply texture offset to our X axis. So that's what their offset there is. And I included it also here. Notice there's a bump map texture offset. There's no bump map actually on our texture. So a bump map is effectively, I can maybe find a good Google image for it. If you're not familiar with a bump map, I'm going to go in here. I'm going to hope that there's no shady images on Google Images, but a bump map, can we see it well? It's kind of hard to tell. But in a lot of 3D games, you'll see kind of like bumpiness and shininess on surfaces. And that's accomplished the majority of the time using bump mapping, because obviously if you were to model like every single tiny little bump or model in a surface, it would get extremely difficult to render like large objects, because I mean you're looking at thousands of polygons for a surface that was this detailed in a game. So what you do is you take what's called a bump map, and the bump map gets, during lighting, it'll effectively skew the surface normals of a 3D mesh. So effectively, it will pretend as if your 3D mesh has a bunch of bumps in it for the lighting, only for the lighting. And so when it gets lit and it gets shaded, it looks as if it's bumpy, but you're still dealing with a completely flat, completely simple cubic mesh in this case, or whatever mesh you want. And so you can, the long story short here, if you wanted to include a bump map on whatever surface you want to scroll, or if you want to edit the bump map, this is here just because you can also manipulate the bump map texture offset. It's an included field in a material. So any questions as to sort of how this works at large? We still have a lot to cover before we go into like a lot of the specifics, but conceptually, do we understand how this sort of works? Okay, cool. So let's go back to the slides. Right, so we were talking about game objects. So all of those things that we saw before were just game objects. So let's go back to the default layout, and then we can look back at our scene. So this is our scene. All of those things were all of our game objects. Those are ultimately containers. I talked about this in a prior lecture, but this is the beginning of an entity component system, in which case these game objects are our entities. That's the entity class, container class for what drives behavior. And the thing that allows us to actually get interesting behavior out of this sort of abstraction is the use of components. And we'll talk about that. So components are all of the things on the right-hand side by default of the Unity editor. So if we're looking at our camera, for example, and we take a look at all these things on the right, we can see that we have something called a transform. We have something called a camera. A GUI layer deprecated, so that's by default. It was imported from a prior version of Unity, so this you could actually delete this. A flare layer, which we're not using. An audio listener. I believe that comes with all cameras by default, though, in case you do want to use it. An audio listener and an audio source. So all of these different pieces are our components. They're what drive the behavior of this game object. So if we can create just a brand new empty game object. Oh, I created it as a child. We can create a brand new empty game object here, right? It's just a game object in our scene. And it's right where our mouse is. Right, well, it's right here. And it does nothing. It has one component, and that component is the transform. Does anybody know anybody guess what a transform is? Yeah.
The position, rotation, scale, etc.
Yes, it is the position, rotation, and scale of a game object. Something that was before, put into 6 fields, or in this case 9 fields potentially, or maybe 3 fields with children, is now an object that we can modify at will. So, well, it's a component that we can modify at will. So if I do this, notice I'm just scrolling the X. It's just moving that transform, which is just the position of that object, and Unity knows to look at that transform component and render our object based upon where its transform lies. Rather than us having to manually set all these things, which we still can do in code, we can just modify them in the Unity editor directly via a graphical interface. It's just an interesting, helpful layer of abstraction. So a transform is a component. A camera, in this case, is just a component. We can attach this to anything we want to, and it becomes a camera. And then we can set it to be either the default camera or not. The camera has a bunch of different things, and I can't claim to know all of the fields of every object in Unity because there's just a tremendous number of things. But clear flags, background, culling mask, all these things that are relevant to sort of how the camera does its job, they're all things that we have complete access to here in the Unity editor. We don't even need to touch code, really, for a lot of things. An interesting, fun thing we can take a look at is if we go to layouts, go back to 2x3, and take a look at our game again. So we have our camera currently looking at the screen here, right? It's just always in one spot. And it has a way of projecting the scene. It can do one of two things. It can be orthographic projection, perspective projection, or orthographic projection. Does anybody know what the difference is between the two, or at least visually? So perspective projection, what that does is it models how real cameras, real lenses, the human eye, etc., behave in real life. Things distort a little bit. And so you see things, depending on where you're looking at them, they look wider or skewed and not like completely geometrical like you would if you were just to draw them at a certain distance. Things have vanishing points, etc. Orthographic, things look a lot different. So notice instantly, so we can see here, perspective doesn't really change a whole lot visually with our helicopter. Things do change a little bit with the background because the view angle is different between the two, the perspective and the orthographic camera. But if we make this a little bit larger, so I'm going to increase the size like that, and I play, one thing we'll notice, what's the first thing that folks are noticing? You can actually see the difference between the top and the bottom. Whoop. How, in particular, I'll put your attention towards the buildings. How do the buildings differ? You can't see the side anymore. The lens sort of curves a bit, and so I'm not entirely familiar with all the math involved, but at the end of the day, what it boils down to is with a perspective camera, you can actually gauge things' distance relative to each other a little bit better. With an orthographic camera, everything is completely flat, and no matter how far away from you it is on the axis that's completely perpendicular to you, it's going to look the exact same. So these buildings are always going to look the exact same no matter how far away they are, no matter which position they are, because everything is just looked at completely flat. And everything is, the view matrix is calculated in a different way. And so just with a simple button, you can change sort of how your game looks completely. You've probably seen a lot of games. I believe Crossy Road does everything with a orthographic camera versus a perspective camera. It has a very distinctive look, especially once you sort of skew things a little bit. But that's just one thing that you can change just without having to touch a single line of code, how your game looks via just the camera's implementation. Let's take things back to how it was. And there's a lot of things like the field of view. So if you want to see more of the game world, so things like in Quake and other shooters, you can change this view, usually in your menu settings, just so you can see more around you. And it starts to look like a fisheye lens a little bit, depending on how you do it. And that's just more distortion of the perspective projection. Yeah, all these things, they all have, I don't know necessarily what every single one of them does, just because there's just a lot involved. And generally, you don't have to mess with it too much. It just ultimately depends on what you're trying to accomplish in your game. And you'll end up finding specific areas of the editor and specific areas of the code base and documentation that you dive deeply into. But this essentially is what a component affords you the ability to do. When you create a component and you attach it to a game object, you can easily not only combine different things to sort of create this emergent new behavior and combination of behaviors for your game objects, but Unity allows you, via different ways of programming the components, to modify them depending on how customizable you want them to be in the editor itself. So you don't have to touch any of this in code. You can just go into the editor and quickly whip things up because of the way that you've modeled all your components. And so we see other things like the audio listener. An audio listener is something that will literally listen for audio and play it back like a microphone to the game player. And then an audio source is an actual source of audio, and so it'll play that audio at the location of whatever that game object is. So we've combined all these things, so now we have a camera that is it's projecting everything with perspective projection, and it's an audio listener, so it's going to listen for audio in our scene, and it's going to play it back. It's also going to play an audio source and listen to itself. And that's just the beginning. We have a whole bunch of other components here, which, I mean, we can take a look just really quickly. So the directional light has a light component, and so a light, you can do all kinds of things. You can make it a spotlight, directional light, point light. All these look a little bit differently. You can make it have a specific color. So if we wanted to, maybe if you wanted like a really dark scene, you could have like a dark light. Or you could even like emulate dawn or dusk with like an orange light. That's sort of how you'd go about doing that. You can bake your lighting, which means that you just pre-compute it so that you don't have to render it in real time when you actually play it on hardware. A lot of different things, a lot of different settings. We don't have time necessarily to go into all of them, but looking through all of these, you can see all these game objects are just combinations of these components, and that combination of those combinations of components are responsible for the behavior that we get in our game. That's the ultimate essence of what Unity is and how it does what it does. And to illustrate the difference, we've talked about this before. This is an inheritance chain where creature inherits from monster inherits from creature, which then goes to goblin, goblin chief, elite goblin chief. In Unity, you could create a game object, right, and then give it a creature component, a goblin component, a patrol component, right? So maybe you want different things to patrol. You can have it like in Unity it'd be kind of complicated, but you could create basically a pathway and then have your entity follow that pathway at a specific time. And then depending on how you've programmed it, you could specify all these different characteristics in the editor. So you could just say on the editor, okay, I want you to go patrol from this range to this range, and I want you to do it with this length of time, pause for this long, right? And then you can give that to anything in your scene. You could make a camera patrol if you wanted to, and then have that be like demo code for the beginning of your game. The flexibility is just insane. Elite component, right? If you want maybe certain enemies or certain objects, if they're elite, maybe they shine bright, maybe they drop more experience or something. A chief component maybe has better weaponry than like a non-chief component. And then a toxic component maybe is like an enemy that when it dies, it like sprays like toxic gas or toxic liquid all over the place. But the flexibility is there. You can ascribe any component to any object to get any sort of behavior that you want to. It's on you, of course, to implement all of these components, right? You're not going to get all these for free. You're going to get a lot for free. Unity gives you a ton of components, really good components. But you're ultimately going to need to program your game logic, and so you'll have to implement all these things, elite, goblin, what it means to be all these things. But thankfully, it's not terribly painful. The way at which we go about doing all of this, and by the way, are there any questions so far as to how Unity's model works, the difference between composition versus inheritance, anything we've talked about thus far? All right. The way at which we actually go about making our own components, which is probably what you'll spend the most of your time doing, at least in the beginning when you're bootstrapping your game, is, programming what's called a MonoBehavior. And so we talked about Mono before. So Mono is the sort of open source implementation of the CLR. And MonoBehaviour, I imagine, I tried to look this up and see where it derives from. I imagine it's because it was originally a Mac exclusive project, Unity. And so because everything was implemented in Mono and because this is the way it's scripted, MonoBehaviour became the name. But a MonoBehaviour is what a component is. They are effectively one and the same. The difference being that a MonoBehaviour is how it's illustrated in code. In C#, if you want to program something to be a component that you can then attach to a game object, it needs to be inherited from MonoBehaviour. Things like, so if we go to coin spawner here. So the coin spawner has, and you can see the difference between what's built into Unity and what's your own via, it'll say script here. So in this case, I have a coin spawner object, right? It's just an empty object, at least in terms of what it displays. It's got a transform, which is irrelevant. It could be literally anywhere on our entire scene. The only difference between this and the empty game object that we saw before is that it has a coin spawner. And this coin spawner has a, this thing here, all components that you add will have the script field here, just to show you that that's the script that that's getting its code behavior from. But also we have this field here called Prefabs, which has a size of 1, because it's actually calculated based on how many elements the list that it's responsible for has. And we have one element, as it says here, and it's got a coin prefab, which is here, this coin prefab. And notice that I clicked on it, it took me right to it in my assets. And so prefabs and all of that, what that means and how to get that all working, we'll talk about that. But a coin spawner script has to exist in our code base before we can actually add it to any game objects, right? So if I go into in my project, usually you have assets, a folder called assets in your Unity project. And then I typically create a resources folder. It's not mandatory that you do so, but just for organization, I'll create a resources. And then I'll have a bunch of folders for all sorts of different things like we've done before, where in the LÖVE2D project at the parent level, you have a fonts, a music or sounds, and then a source directory. And here, in this case, we have fonts, materials, models, all the different assets that we will need in our game, but also a scripts folder. And all the C# scripts here, all the C# scripts here that we'll use amongst all of our components, all of our game objects. And so you could easily just go to any of these rather than have to go into your operating system, open up a new window, and find your file and navigate through all the files that Unity generates for you, which can be kind of a pain. You can just double click on a coin script, for example, and it'll open in your default editor. And so one thing that I'll just mention here is if you go to your Unity preferences, on Mac it's Unity and then preferences, you can go to external tools. So by default, starting in 2018, Unity is transitioning away from its prior IDE, which was called MonoDevelop, which was a good IDE. They're transitioning away from that, and they're making it focused on Visual Studio as the default IDE. I don't use Visual Studio. I like VS Code. So what I did was, and what you can do, is you can choose your external script editor here, if you prefer a different script editor like Atom or VS Code or Sublime Text, and then just browse for it on your file system, whether you're on a Windows, Linux, or Mac machine. And then you can easily just choose which file you want. In this case, I chose VS Code. And so the effect that has is whenever I double click on a script within Unity, it'll actually open the IDE or text editor that I have assigned to it in Unity's preferences. And so here is the coin component that I have created for this example. And notice that every component, first of all, is a class. And actually, everything effectively in C#, just as in Java, is a class. It's a public class. And notice that I call it coin, and I got this colon and then MonoBehavior. So this colon, anybody take a guess what the colon means? Tony? Extends, yes. Extends or inherits from MonoBehaviour. So anytime you have a component that you want to create and you want to add it to Unity and allow you to see it in the editor and allow you to actually drive behavior of an object, you need to inherit from MonoBehaviour. Like it says here, my VS Code, since I have the extension for OmniSharp, it'll actually tell me MonoBehaviour is the base class from which every Unity script derives. There's a couple things here. So notice that we have a few methods. So void start, void update, and void on trigger enter. So anybody take a guess as to what, ignoring on trigger enter, does anybody have a guess as to what start and update do? Yeah.
It would be just like init and update in LÖVE.
So say it one more time.
It would be just like init and update or in LÖVE.
Exactly. It'd be just like we did before when we created objects in our LÖVE 2D projects, where we had an init function assigned to every class and an update function assigned to every class, and we would call those ourselves. Every MonoBehaviour can have a start method. In this case, it's empty because every time you create a new script via the Unity editor, it will automatically, first of all, it will automatically create a brand new file for you. So if we want to, let's just say I want to create a new script. So if I'm in the Unity editor and I go to my assets, I right click, create, and then I want to create a new C# script. It'll create it there. I can say maybe I want this to be, I don't know, test component, right? So this should have the effect of when I open it in my VS Code, this test component, this was auto-generated for us. We didn't have to write any of this boilerplate. But every MonoBehaviour, or every script that you create, rather, by default is a MonoBehaviour, which it now strictly does not have to be. You could create a class of your own that maybe you call behind the scenes, or maybe it just represents a data structure or something. But by default, anytime you create a new script in Unity, it'll save you the hassle of typing out all this stuff by hand, and it'll give you an empty start method and an empty update method. And so like Tani said, the start method gets called as soon as the object that it's assigned to gets instantiated. As soon as this component gets instantiated, rather, which usually often is the case that it gets instantiated at the same time as a game object. Not always. You can create game objects or components on the fly. But this start method will get called. Anything that you put in here will get called right away. And then this update method, Unity will every frame go through every component on every live game object and will call the code that's contained within this update function. And you don't have to call this anywhere yourself. Just by assigning this component to something in your scene, assigning the component to a game object in your scene, you get the sort of update and start and all this other functionality given to you for free. And MonoBehaviours are actually much more complex than just start and update. So if you go to MonoBehaviour, Gesundheit. If you go to MonoBehaviour here, we can see that, by the way, I want to shout out Unity's documentation. Unity has amazing documentation. docs.unity3d.com. You'll go through pretty much everything you possibly could ever want with every object implemented in Unity in quite a good detail with a lot of examples. But here we can see, just in the description, it'll tell us the MonoBehaviour will get start, update, fixed update, late update, on GUI, all these functions called for us, assuming that they're implemented. And you don't have to implement them if you don't want to. If they're not implemented, they just won't happen. If there's no start method, then that means there's no start logic for this component, so it doesn't need to execute. If there's no update, maybe it just needs to start at the very beginning, but never update after that, don't implement update, and update will not be called. All of these are optional. That's just a small chunk of MonoBehaviour, though, because you also have messages. So messages are functions that you override. As you can see, there's a whole lot of them. And all of these messages get called depending on certain things that happen in the game scene. So on trigger enter, for example, if our object is a trigger and we enter it, then the behavior will get called in that function, which will allow us to do things like if our helicopter enters a building, we can call that helicopter's explode method, which is literally what we do in this project, thanks to this function. And all we really need to do is just a couple lines of code. It's very simple. On post-render, on pre-render, all these different things are called at different times. You can look into all of these if you want to, just by clicking on them and looking at their documentation. Late update is called after all update functions have been called. This can be relevant for physics, certain physics calculations, but there's a whole lot of different things you can do. You don't necessarily need to do a lot of things yourself if Unity provides you with the function that gives you the effect that you're looking for. And so if you're curious, MonoBehavior and then the docs at large, this is just all the documentation, just an insane amount of documentation. And that's just in the classes. There's all these other little side areas as well. And so that's sort of what MonoBehavior is. It's a component. It gets a lot of these functions called for you. You don't have to implement them, but if you do, you get a lot of functionality for free, basically. Any questions as to what a MonoBehavior is, how it works, and so forth, or any of the syntax we've seen thus far for creating a MonoBehavior? All right. And so here in our coin, for example, which we were looking at before, notice that I'm referencing something called a transform. Transform.position.x is less than -25. Destroy GameObject. If this is the coin, what do we think that this is accomplishing?
It goes off the screen and get rid of it.
Yep. So the transform, recall, was our object our component that encapsulates our rotation, scale, and position. So we can just say, if transform.position.x is less than -25, destroy GameObject, because we're spawning the coins dynamically when they get off screen, just like we did with the pipes, if you remember. And I had a screenshot actually in that slide that sort of showcased what that looked like. We can see that exact thing alive here. If I go to layouts 2x3 and we play the game again, and then I'll just die at some point, but if we do this, right, we're seeing our scene live. So we're following this. Yep, see how the coin, as soon as the building and the plane and the coins all get to this point, this is -25 in Unity units, not in pixels. Everything in Unity is based on Unity units, which by default 1 is equal to 1 meter, as opposed to, we've been thus far using just pixels, but pixels aren't viable in 3D. But that's effectively what that component does. It's checking in our update function, void update, if transform.position.x less than -25. And notice that we don't actually have to declare transform anywhere, which is interesting. That's because MonoBehavior by default gives you access to its GameObjects transform, just by default. That's just something you get for free. And then notice GameObject, we haven't declared GameObject anywhere, because by default we have access to GameObject. It's the GameObject that this script belongs to, that this component belongs to. This would be the actual. So the interesting thing about classes is you don't have to explicitly say this, because if you had like int my number equals 10, and you just say my number, the difference between like Lua and like C# and Java is that my number, it'll already know what my number is. This is my number. It'll know it's this object's. You don't have to do that. Sort of a nice little thing to save you a little bit of time. Yeah, because you could then just say my number plus equals 10. Another nice thing about C#, by the way, which we didn't get in Lua, you can do compound assignment operators. So you can do plus equals, minus equals, times equals. That's one of my pet peeves I have with. Oh, and notice that also the nice thing about the fact that I have OmniSharp, it'll underline, and this is just a trait of most IDEs, honestly. So you get this with a lot of places, but it'll tell you my number is not assigned, and with the underlining and also just by hovering over it. The name MyNumber does not exist in the current context. But I can just say int MyNumber, and then it's gone. A little bit more that we have to worry about, and a little bit less that we have to worry about, a little give and take. But still, I think overall, C# is going to be a lot more syntax heavy. You do have to worry about things like braces and semicolons and, putting everything in kind of like a boilerplate, and then, obviously type declaration and return type declaration. It can be a little bit more than we've gotten used to so far, but it's honestly not too bad, just given that you can use IDEs. First of all, the fact that you're statically typing everything, you can detect a lot more errors in advance. If you're trying to do something with some type that you're not supposed to do, like some function accepts some object of some type, but you're passing in some other object, you'll catch that in advance. And so that's a really nice thing. But yeah, it's kind of it is a give and take. And also IDEs will give you, like I said, a lot of the functionality, a lot of the autocomplete that makes a lot of this more sustainable. And that's not to say, of course, that Lua and LÖVE2D don't have their own IDE. Like Zero Brain Studio is popular from what I understand. Haven't used it yet, but particularly when you venture into Java and C# and compiled languages, static languages, having those features, it does save you a lot more time, relatively speaking, than when you're in a dynamic language. So yeah, that's what MonoBehaviours are. Every component of our game effectively has, like the helicopter has its own script, a heli controller. The coin has its own script, the coin spawner, the skyscraper spawner, the skyscraper. They all have their own scripts that drive their game behavior, but they also have scripts and components that are part of Unity core as well, including colliders and triggers. So if I'm looking in Unity, so I'm going to go to and this will actually be the last thing we look at before we take a break, but if I'm in Unity and I'm going to go back to my default layout, just because it's a little cramped on a 720p, go to my helicopter. Helicopter's got a couple pieces to it, so let's actually go to where I can see it here. So one of the awesome things I love about Unity is it gives you a lot of this editor magic, this editor sort of sugar. It shows you visually where a lot of the things are in your game world. So the green rectangles, anybody know what those are or can guess? Yep, hitboxes, exactly. These are colliders. So the blades doesn't have a collider. That blades collider is actually separate. The box collider here is this collider right here. And so a collider is literally just something that collides with something else. And you can set it to be a trigger or not. If it's a trigger, then it actually won't trigger the onTrigger callback function that we've briefly saw earlier. So the things that you want to activate triggers, you should make those not triggers. And then triggers, all you have to do is just click this little trigger button. So what a trigger is just a region that you've determined or some object that you've determined should cause behavior when it gets triggered. So in this case, I've assigned, actually we could go to, I'll just play it. But the airplane's a trigger, has a trigger, right? Every building has every building, all of these things have colliders, whether they're triggers or not. The helicopter, its blades and its body, there are two colliders, two boxes. The coins all have colliders. The skyscrapers all have colliders, and the airplanes have colliders. The difference is that, oh, and by the way, another cool thing, it's easy to get very sidetracked just because there's so many cool things to talk about. You can pause the game while it's running. So it's paused right now, but it's in the exact state that I left it. So there's 3 coins there. I got my helicopter there. I can freely go about the scene. I can analyze things. I can actually modify this in real time. So I can change its rotation if I want to. Probably don't want to do that, but I could if I want to. I can change its position, right? So I can move it left or right like that. And then notice that I actually have just the body selected so that the blades are kind of separate. I don't even know what kind of crazy stuff would happen if I just like mess with this and just let it run. I haven't tested it that crazily, but you're allowed to step through Oh, okay. It looks like they both just go. Yeah. Oh, yeah. Because they're parented to the helicopter object, so they're both going to align. They're both going to move at the exact same rate, regardless of how far apart they are, the individual objects. But you can just step through your game's execution frame by frame and get a sense of if you're trying to pinpoint like a bug, maybe that's position based or something that's kind of tricky and you just haven't been able to find exactly what's going on. You can look through you can look through your whole scene and all of the fields of every object in real time, just by, not in real time, but in step time, just by stepping through this button here, assuming that you're in pause mode, and then just looking at all the components here on the right side. Because those will all still update. All these fields will update anytime you perform any changes in the actual scene. So super helpful for debugging. I know I've used it a bunch. And then if I start again, or if I stop it, the nice thing is any of the changes that you make while it's running to your object, they don't get applied when you actually go back to the game. So notice that I messed with the two pieces. I sort of separated them, and then I stopped the game. It ended up going right back to where it was in the very beginning. So all this gets just basically saved like a snapshot. You can do whatever you want during your game, and then come back to it, and it'll all get reverted back to where it was. Yeah?
So I was experimenting with Unity in single player, and I kept making changes while I had it paused and then losing it. It drove me insane.
Oh, yes. So yeah, Donnie just basically echoed what I just said, which was if you make changes in your game while it's running and you're trying to maybe tweak them such that it's perfect when you're actually done, they don't get saved. So you have to actually make a conscious effort to remember what you've done, how you've changed different fields to fix any bugs if they do exist. But it is, yeah, something that can be disheartening or frustrating if you finally fix something and then you forget what it is you changed and then you have to mess with it a whole bunch. So remember all the changes you make if they're pertinent to your actual game's execution and the debugging of your game. And then there's also a console as well, which is nice. If you want to sort of output things sort of like JavaScript style in the web, you can do console.log. You can do the same thing with a debug call here in Unity. I don't have any of those calls in the actual game, but it is something that we'll look at going forward. And it is something that can be very helpful if you want to measure something or output something that you can't necessarily look at in the inspector. In the case of this game, most of anything that we want to take a look at is visible in the inspector. But if you have an algorithm, maybe you have a generator that's not visual, maybe you're like a level generator and you want to like make sure that the data structure representing your level is generating things properly, you can output everything maybe via hash marks or something in your console and actually see it that way when you're running the code rather than having to run the actual game and look through it that way. Some things just are hard to model in the editor and still need console output. So that's the console's there to sort of help you. And so debug.log is the function, I believe, that you need to see all that stuff. Right, colliders and triggers. So we had a little bit of a tangent there, but the helicopter is comprised of these three things, but the blades collider should have ultimately been merged with the blades object here. But we can think of it as the blades and the body. The reason they're separated, well, there's two reasons they're separated. One is, one core reason they're separated is they're just different sizes. So the blades are longer than the body, and so we have, for that reason, two separate colliders. So we're looking at the helicopter here. We can see that the collider for the blades extends a little bit farther than the body. We don't want to create a box collider for the entire helicopter because a box collider that's like that goes out here, for example, might not be super fair if we're just coming right over a building and our body kind of maybe the building's right here and we just miss it. We don't want that to be collided with. So sometimes you'll need to combine colliders to accomplish the collision detection behavior you're looking at. The nice thing about box colliders, which we're using here, is that they're not very expensive because they're just boxes. It's easy to compute 3D box collision with other things that are 3D boxes. So, and that's actually sort of a topic in its own, is taking a complicated model or object and then breaking it down, not in terms of what it looks like to be collided with, but how you can simplify the collision detection of something like a character by just modeling its arms, its body, its legs as like cylinders or boxes rather than complicated geometry. You usually don't want to do pure geometry collision for anything because that gets really expensive. you want to try and aim for simple shapes to be your colliders. And Unity gives you a lot of simple shapes by default. If we look at, like for example, in our helicopter, if we wanted to add a component, which by the way you can easily do here, just in the component inspector. If you're looking at the bottom right, there's an add component button. So you can add any of the components that you've written and also all the components that Unity gives you by default. So if we look up like collider, we can see there's a lot of different colliders that Unity gives us for free. Polygon collider, mesh collider, box collider, capsule collider. I try and strive for boxes as much as I can. Spheres aren't bad. Spheres are usually fairly easy to calculate as well, but boxes are the easiest. Capsules are pretty easy too. A lot of players will be sort of capsule colliders because characters usually have rounded heads, so emulating the collision for their head with a capsule sort of makes more sense. And we'll look at that actually next week when we use a first-person component that we can get for free. The default collider for it is a capsule. So, but the blades or the blades and the body both have their own collider. They're not triggers, but if we look at our prefabs, which we'll take a look at what a prefab is shortly, a skyscraper has a box collider, which is a trigger, as we can see here. And the coin is a trigger, and the airplane is a trigger. So these things all trigger, they all accept other colliders that aren't triggers, and if it detects a collision with a collider that's not a trigger, it will call the onTriggerEnter function, which we saw is something that you can get with MonoBehavior. Yeah?
Could you have two bodies, like if you want to call a special function and two at the same time have the regular distance collisions? Or is there some easier way to do that?
Can you give me a specific example?
Well, if I want to have a pinball game or something, and I want to call a function when my ball hits something, but at the same time I still want it to bounce off of stuff.
Oh yeah.
Is there any way to do that? Or?
So the question was, can I implement such that, like for example, in a pinball game, if I have a ball that collides with something and causes a trigger to occur, but also have it bounce off of something, and you would do that with a rigid body. So you give it a rigid body. In this case, I actually gave a rigid body the helicopter because the original goal of mine was to have it be affected by gravity, but it turned out that I actually liked it a little bit better without gravity. So this rigid body isn't strictly necessary, but it has a gravity component that you can assign to it that will actually then calculate gravity and pull it down wherever you have a global gravity definition that that's in your Unity settings that will affect it that way. And so what you would do is you would give your ball a rigid body, and other things that you want it to bounce off of, those would also have sort of rigid bodies, and they could be static or kinematic or not, basically, which we talked about before. Kinematic can move but not affect but not be affected by other objects. And so the object that's a trigger, you still trigger code that does something. So your pinball machine, when it collides with something and it triggers that thing, it'll still trigger that code. So whether that's increment your score or cause something to flash, a particle to flash or play a sound, it'll do that in your onTriggerEnter, but your rigid body will also perform its work and bounce off of whatever assuming that you don't destroy it with that onTriggerEnter function, it will bounce off of that surface and behave in the way that you are alluding to. Does that make sense? All right. Cool. So so all these things have triggers. The isTrigger flag, that's as easy as we need it to be. So we just give a box collider. And the nice thing about box collider too is if your mesh is a box or square or rectangular, it'll usually just fit it perfectly to whatever you're trying to assign it to. So in this case, I remember adding the box colliders for these skyscrapers. It just, because they're all rectangular or cubical, quadral, I don't know, what's the rectangular 3D? I forget the term. What is it?
Rectangular prism.
Rectangular prism, yes. Since they're all rectangular prisms, the box collider fits them, it'll scale the right way. When you have differently weird shaped objects, it'll just basically be as big as it needs to be to completely encapsulate it. But like I said before, because the helicopter's got some weird geometry, if we were to do that, it would by default just be this entire box here, because this is the farthest it goes out on this particular axis. So we want to combine meshes to produce the collision sort of behavior that we're looking for. And the trigger enter bit is relevant because if your game object is a trigger, right, then once we collide with that object, we want, and by default, when you do onTriggerEnter, it'll look for the collider on this object. It's going to take in a collider other, right? And what that is the other collider, the thing that's colliding with this object, with this coin. So the helicopter, because it's the only other object in our scene that has a non-trigger collider. OnTriggerEnter, this is going to be a helicopter. We can just say other.transform.parent, because our helicopter has children which have the actual colliders, and our parent has the helicopter controller component. We're going to get component at the heli controller. So we're going to go through that object that collided with us. We're going to get its transform parent. We're going to do get component, which is a function that will just look through all of its list of components. We specify which component we want using this identifier here, so of class heli controller. And these sort of angle brackets are like the generic, like the sort of generic type specifier syntax, which basically looks for it. You could pass in any type here effectively, and get component will look at whatever type is in here and get the component of that type specifically. So you do have some sort of type flexibility in C#, but you have to go kind of the extra mile and specify it and implement functions that take generic arguments like this, which is similar to Java and C++ and other languages that do it that way. And then once we've gotten that component of type heli controller with this function call, we execute pickupCoin, which is a function that's part of the heli controller. Any guesses as to what pickupCoin does? Sorry? Increments the coin counter, calls the coin to disappear. Well, it actually doesn't call the coin to disappear because we do that here. Oh. Destroy game object. Game object is going to be this coin that's executing this function. It does one more thing too. Do you remember what happens when we pick up a coin? Particle, exactly, the particle effect. It triggers a particle effect. We can go to the heli controller class and take a look at that. Pick up coin. Here, coin total plus equals 1. Get component, audio source, play. So it's a little bit weird. So with audio source, you can have multiple audio files. So get components audio source is what we need to actually get the audio attached to this object. And then at index 0, because there's only going to be one audio source anyway, and then we just call play. So that'll play the coin sound. And then get component, because there's only going to be one particle system associated with this helicopter object. We're going to get the particle system object, and then we're just going to call play on that, which will actually trigger an emission one time of its particles. And so that's sort of in a nutshell what colliders and triggers are. It's a lot of syntax at once, just because Unity's kind of really big, but it's pretty simple. Just make sure that you give the right shapes to your objects, make the right things triggers that you want to cause behavior to happen when like non-trigger things touch them, and then implement onTriggerEnter with the behavior, the game logic that you need. In the case of the skyscraper, for example, if we look at the skyscraper, so I have a skyscraper component here, and then if I onTriggerEnter here, it effectively does the same thing that the airplane does, which is just go through the others, transform parent, game object, heli controller, and then call explode. And so explode kind of is a similar thing to what pickupCoin does, in that it triggers a particle effect, but it also destroys the helicopter, and it tweaks the game over text to turn on at that point. So any questions as to how triggers work? Any of the syntax we've talked about thus far? I know that it's kind of a lot. It's kind of a fast tour, but moving right along. All right. Oh, and here's a screenshot I took just to illustrate the green lines, the box, and then the orange is the actual mesh of the helicopter. So we're going to take a break, And then when we get back, we're going to talk about prefabs and spawning them, and dive a little bit deeper into some of the other parts of the project. All right, welcome back to GD50 Lecture 8. This is Helicopter Game 3D. So before the break, we were talking about colliders and triggers, and also just getting our hands used to using MonoBehaviours and the editor and all sorts of things. But we haven't really taken a look at prefabs, which is a major part of this game. So the coins, the skyscrapers, the airplanes, those are all prefabricated assets that we have sort of gotten ready for spawning into our scene. And we're going to take a look at how that actually works. So here's a list of, in our editor view, all the different prefabs that we have. So we can see airplane, blades and body are prefabs, the coin, all the skyscrapers. There's 3 different kinds of skyscrapers, and then the helicopter. The helicopter itself we're not using as a prefab because I've already created it in the scene and it never gets instantiated dynamically, but we could easily make it so because I have created a prefab with the helicopter. So when we're looking at the scene here, we notice that we have just the helicopter and we have the background, but there's no skyscrapers, there's no coins, and there's no airplanes. What we do have are skyscraper spawner, the coin spawner, and the airplane spawner. And the 3 of those are just empty game objects, but they have associated with them these spawner scripts. And the spawner scripts we've written ourselves. And then once we've written them, we've just simply add component here and then chosen the appropriate spawner. And so what those do, if we look in our code, actually, and we go, for example, to the airplane spawner, we have a start method, we have an update method. Notice that the update method doesn't do anything, paradoxically, because, I mean, the airplane spawner is running over time. We are spawning airplanes over time. But the way that we do things over time, sort of asynchronously in Unity, is a little bit different than anything that we've done so far. So this start method here, we see that we're calling this function called start coroutine. And that function takes in a function called spawn airplanes. And so at a high level, a coroutine is effectively a function that yields control every time it's called. So it'll run, and then rather than go through its entire body of code and then end or return some value and have that just be the end of it, it'll actually yield when you use the keyword yield. And depending on what you've done with that yield, it'll pause for some length of time or do something for some length of time rather than end that function call. So this spawn airplanes function here, notice that it has a while true. And so while true is not usually something that you want in a game because that's just going to lock your game forever. But in the case of a coroutine is going to run, but then it's going to yield control back to whatever called it for some length of time, or depending on how we've programmed it. In this case, you can see here, yield return new wait for seconds, random.range 310. Does anybody have an idea of what that does? Yeah.
Well, I mean, it presumably just waits between 3 and 10 seconds and then continues.
It does.
Okay.
It yields for 3 to 10 seconds and then continues its execution. That's exactly right. Did you have a question?
Well, I was just thinking, why do you have 3 different skyscraper setups? Couldn't you just have one skyscraper and assign the skin randomly?
You could do that, yeah. I guess for the sake of demonstrating prefabs, and also it's a little bit more complicated to get into like dynamic material setting and like changing materials in code. But yeah, you could effectively just create 3 separate skyscraper, or one skyscraper with one like base color, and then dynamically change its material, but also to illustrate having multiple different prefabs assigned to an object that you can then choose at random to generate in the game scene. They might not necessarily be skyscrapers that'll have the exact same color. It could be like a goblin or a orc or a troll or something, and they're all different prefabs that we've created, but you can put them in a list and then dynamically choose which one we want at random. So a few different reasons, but yeah, in a situation where everything is just effectively differentiated by a single color and a material change, you could dynamically swap that as needed. So this coroutine that we've started, this function that effectively can pause itself even though it's being called infinitely, it's being called, this while true is in play. It yields control with this yield keyword, and what it does is it allows us to call something over and over again, but then pause for some length of time, right? We don't have to maintain a counter for spawn time in here, which we could do. We could do like float spawn time equals 0, right? And then float spawn increment equals like 1,000, and then while spawn time is less than spawn increment, or we could say in update if spawn increment, or we would do spawn time plus equals time dot delta time first to get the length of time that's passed since the last frame, and then we would say if spawn time is greater than spawn increment, instantiate a new skyscraper or airplane, sorry, and then set spawn increment or spawn time back to 0, and then just rinse and repeat this over and over again. But coroutines take out this need, much like timer did, for having anything that you keep track of with a specific timer. You can do a whole bunch of different things with coroutines. One of them, in this case that we're doing, is just pausing for some length of time to do something. In this case, we want to wait for some time in between each call to or in between each instantiation of an airplane. So we'll just yield control back to our game because we want to break out of this while true, but we don't want to break out of it and completely break out of this function. We want this to keep going over and over again. So we see here this instantiate function is sort of where the actual instantiation happens. And instantiate takes in a prefab, so a game object. So in this case, we have a prefabs list here, game object, public game object array called prefabs. So this can take in any number of prefabs that we want it to. We're going to return a range between 0 and length. And then also, we want it to spawn, we give it a position that we want to spawn in. So instantiate, it takes in an object, it takes in a position, and it takes in a rotation. In this case, we want to give it this position. So it's a vector 3, gets an x, y, and a z. At 26, so off the right edge of the screen, 7 to 10, so kind of like within a range of verticality up towards the top. And then at 11 on the z-axis, which is aligned with our helicopter and the skyscrapers. And then this quaternion.euler is so 3D rotation is, the math behind it's pretty complex, and I don't know it well at all. But quaternion.euler allows us to think in degrees and actually perform a 3D rotation on something fairly easily. So if you want to rotate something in 3D, quaternion.euler, negative 90 degrees on the, I believe it's z, x, y. In this case, the way that the default rotation of the airplane is, we want to set it to negative 90, 0. You could also set up your prefab in a way such that you don't need to pass this in. You could do quaternion.identity in that case. But this is just to illustrate how, if you want to rotate something in code, how you would do it. So quaternion.euler is the way that you rotate something in 3D. And so instantiate, global function that you can call anywhere you want to, as long as you just give it a actual object or prefab that it knows how to instantiate. And then wait for seconds, another global object, which is a asynchronous object that will allow us to yield for this length of time. We pass in the length of time here. It takes it in seconds, because wait for seconds. And then as soon as this length of time has passed, it's going to come back up here into this while true instruction and then instantiate again. We don't have to keep track of a timer or anything, any weird boilerplate. We just have to call start coroutine here. And notice that we explicitly have to call start coroutine in order to trigger a coroutine function. And to do that, it returns what's called an I enumerator. And so a lot of these details you don't need to necessarily know the low-level details of. I certainly don't know all the low-level details of everything that happens in Unity. But just know if you want asynchronous behavior, your function needs to return an I enumerator, which C# knows is an asynchronous. It's not asynchronous, it's a generator function, which will yield control at predetermined times, and it will manage it for you. And to trigger it, you need to start coroutine, which is a function that Unity has defined for you. So any questions sort of as to how this works, at a high level at least? Yeah, so it's a yield takes in something and you get a new, like to instantiate a new wait for second, you have to, it's just the way that the syntax is for yielding an object. Yield, it's returning this to the yield instruction, and the yield instruction is then yielding that. So it is a little bit weird though. But you only really have to, like this is a common pattern that you'll see, and so you'll just get used to it. So, and honestly, this is probably like one of the more syntactically difficult things about Unity. So, I mean, as soon as you understand this, pretty much anything else is fairly easy at that point. I would say this is one of the weirder sides of, because I mean, in Lua, I'd love 2D and like those kinds of environments, it's a little bit easier to do that sort of thing with as much syntax. C# being a statically typed environment, to get the same behavior, kind of have to go a little bit further, do things their way. But that's getting asynchronous behavior to work in C# and in Unity. Typically, in order to avoid sort of like messy state management, you will use coroutines, which are I enumerators, often with the wait for seconds object, and just make sure to trigger them with start coroutine, and then call that function as if it were an object, just like that. And the behavior for the airplane spawner, the coin spawner, and so forth, they're all fairly similar. So start coroutine, spawn coins, and then while true, so coins, this row is just, it spawns a random number of coins vertically. So you can have one, or you can maybe have a couple. And then for each of those, instantiate them at a random position on the y-axis here, random -10 to 10. In this case, quaternion.identity, because we don't want to rotate them any differently than they already are, which I alluded to before.
What is that?
So quaternion.identity just means no rotation applied to the object. So whatever its base rotation is as a prefab. So it'll be whatever it is when you see it in the editor, and when you create a new one, that's going to be its default rotation. So basically, the equivalent of don't rotate this by anything. And then same as we saw before, yields a new wait for seconds, in this case 1 to 5. So a little bit more frequently than the airplane on average, more coins. As the airplane, I believe, was 1 to 10 or 3 to 10, so every 3 to 10 seconds. And that's basically that. And then we start coroutine just like we did before with the airplane spawner. And then lastly, the skyscraper spawner. In this case, we only have one coin prefab, we only have one airplane prefab, but we have 3 skyscraper prefabs. And so the actual random.range here comes into play, because that's how we get, the different color skyscrapers spawning at random. And like I said before, this can be extrapolated to whatever sort of game environment you want, where you have multiple types of objects that are more complicated than just a color swap. And you want to choose them at random. We're doing all the same things that we did before. And also, here we can see that they have a random chance, 1 in 4, so a 25% chance of increasing the speed. So skyscraper spawner actually has, and this is relevant to the assignment, skyscraper spawner has a float called speed here, which is by default 10, and this drives the speed, the scroll speed of the skyscrapers, the coins, and the airplanes. And so when we call it static, do we know what that means? Yeah?
Well, it's the same for all objects.
Yes. So no matter how many skyscraper spawners we create, only one, they're all going to share this field, speed, and it's always going to be equal to the same amount across all instances. So static means that it's part of the class. It belongs to the skyscraper spawner class. It does not belong to a skyscraper spawner object. And so we don't ever really want to change that ourselves in this game. But the airplane, for example, notice that in our update function here, if the transform.position.x is less than -25, we should destroy the airplane. So when it goes off screen, we should destroy it. But if not, then we want to translate this object on the x-axis by negative skyscraper spawner.speed times 2 times time to delta time. So we're translating it on the x-axis, and we're using the skyscraper spawner.speed as our core multiplier. And then if we do this, if we look at coin, same thing. Every coin, and notice that, or I should ask, what is one sort of design consideration if we're looking at this, all these components, and let's say we're trying to get as sort of decoupled as we can and well engineered as we can. What's a consideration that we can noticing that, for example, this exists in coin and this exists in airplane.
What's the question?
So how could we better engineer this? Notice that we have, and taking into consideration this component model in Unity, what could we do with, for example, this?
Would that maybe be better in the coin spawner class?
Well, I'm thinking that because the airplane and the coin, well, first of all, it wouldn't belong in the spawner because the spawner's job is just to spawn coins. But the coins and the airplanes, they have their behavior, right? They have their update behavior. But they're all doing kind of the same thing, which is scrolling to the left and then despawning at negative 25. So a design consideration here would be maybe we have a scroll component, right? We could set like a scroll and destroy component, or just a scroll component with an optional destroy flag. And then we just put this on anything that we want to automatically scroll to the left screen and despawn, rather than having to code this in every single class. So if you're ever looking through your code and you're seeing, for example, this and this being the exact same, especially in Unity, because of the way how flexible components are, try and think about how you can make it into its own component. So
where would you put the coins?
you make it yourself. So if we went into here, into our scripts thing, and just made a new script, and then we called it like scrollable, and then we double click it, it'll open up in our editor that we've chosen in our preferences. By default, it's going to be Visual Studio with the newer versions. But now we have a new scrollable behavior. And then all we need to do, we would say if dot, oops, not that. If transform dot, once again, I can't type, transform dot position dot x is less than negative 25, destroy game object, right? And so this is the exact same thing as all that behavior that we saw before. So now we can take all of that out of coin. We can take this out, and we can take this out here, and then just add to the airplane and to the coin prefabs. We just add this new scrollable prefab, and then it'll take care of that for us. Yeah.
How would you add
So if we're going back to Unity, so the question is how would you add the prefab? Or how would you add the component to the prefab? So in our prefabs, note that we have airplane, we have coin, and we have all the skyscrapers. So these are all prefabs. Oh, and I haven't actually detailed how to create a prefab, which I apologize for. So a prefab, all you need to do is create an object in your scene. For example, I did it with this helicopter, so I'm going to delete the helicopter. Because this is just a helicopter prefab, it's not going to actually delete the helicopter from our scene. But if I take this helicopter here, and then I drag it in here, notice that now we have a prefab here. So this is, it's going to be, we could take this helicopter out and just add a new one, like right there. So now I have 2 helicopters. So that's all a prefab is. It's just something that you've made in your scene that you want to replicate or duplicate in the future, ideally through code. And notice it's showing here in our sort of hierarchy view, but obviously you don't want that. But that's how you create a prefab, is you find something that you've sort of configured in your game scene, and then in your code, you're allowed to then instantiate that prefab, assuming that you've made that prefab a member of whatever you want, whatever class instantiates it. So in this case, the airplane spawner. So notice that we call instantiate here, like we saw before on line 24. But it's looking at prefabs. This sort of, it's a list, and it's looking at a random range between 0 and the length of the prefabs. You have to declare public game object list prefabs here. And then once we do that, and we go to our airplane spawner here, notice that we have this prefabs list here. So we actually get a editor view of that code data structure, and we can just add prefabs that we want to. And if we change the size to 2, then we can add a second prefab. Or if we make the size 10, then we can put 10 different airplanes there. But we only have one airplane that I modeled, so I'm just going to make it 1. But this is the same thing. This GameObject list is that same list, only that's the view we have of it in the editor, and it's the same. It's just like a different way of looking at the data. And that's sort of the nice thing about Unity is that you can, if you make any of your fields public like this, like public, if I did public int like some number, right? And I save that, and I go back here, my airplane spawner should get some number right here. And then I can just set some number to whatever I want. It doesn't do anything right now because some number doesn't affect the script. But this is a nice way to take the burden from you out of the code and like you're not experimenting with code. You're not tweaking some variable in your script. Some number 10, run it. Okay, some number 12, run it. You can just assign it here in your actual editor view, and then just tweak it as you want. So I just scroll through it. I can start the game, and I can pause the game.
It shows up there if you just if you make it public.
You have to make it public, exactly.
Public, and then it shows up.
Yep. And so I can just do this, and then I should be able to. I can just change this now if I wanted to like 67. And so if that actually had some sort of effect on my game world, if my game relied on that number being meaningful, this would update the scene. And so you can make whatever, you can debug this way, or you can customize your components more this way, but it's just a tremendous amount of flexibility. And so that's how we're instantiating this sort of from this list of prefabs. It's a list of game objects. We've made it explicit to Unity. The editor's going to know, okay, these are game objects, and so prefabs are game objects. So we can just put any of these into this field here, this element 0 field, or however many fields we have, and it'll in the code randomly choose one of those and then instantiate it. So any questions as to how prefabs work or instantiation or anything like that? Okay.
So each prefab has a unique number or not?
Does each prefab have a unique number? Not a unique number. They just are all assets in your folder here. They have some kind of identifier to Unity that's hidden from you. It might be visible from you if you look. They might have some sort of generated ID or something like that, so that it knows underneath the scenes. But it's not something that you worry about in your actual code. You just tell, like, we've created a list here that's just, it'll expect some number. It doesn't know how many. And then in the editor, you can actually tell it how many via the, because every list that you assign to, that you make visible in the editor will have this size field. And that's just part of the editor's abstraction. The editor has abstractions for a lot of different objects. You can create a lot of different objects in your MonoBehaviours and make them public, and Unity will have a different view for them. Things like color pickers and stuff like that. Like if you actually, I don't know the exact object offhand, but if you make a public color picker in your MonoBehaviour or something like that, you'll actually get a color picker here that you can choose a color for, which is pretty awesome. And there's a lot of different like customized views. Like all of these, like the I think actually the directional light might be an example. See this color here? Like this is somewhere in code. Like there's a public color something. And then in the editor, when you're actually editing it, you can choose the color, and Unity gives you the option to like make it whatever you want. And notice it's actually affecting the background there. So this is like one of the really big strengths of Unity, and a reason to really make your components customizable is this sort of one-to-one mapping between your data, your code, and your editor view of the code, of the data. Take the burden away from you programming it, which you're more prone to make mistakes too. And also waste a lot of time, and then just be able to modify, like how much faster is for me to just say I want this red color rather than like color.r equals something and then color.g equals something, color.b equals something, and then assign it that way. So I mean that's just a simple example to illustrate it, but there's a tremendous amount of potential involved in making your components customizable. And so that's what I did here. Because I wanted the airplane spawner, or the specifically the skyscraper spawner, to spawn one of not just one skyscraper, but several skyscrapers. I created this public prefabs list that I can then populate from Unity here and say, okay, this object, and this object. Put that into the skyscraper spawner here, these slots, and then my code knows to instantiate it, randomly picking one of those.
In your example earlier about, so how would you actually go about making something scrollable now that you made that component? So you just like add component to the coin.
How would you go about making something scrollable now that you've...
Yeah, you declare that scrollable class, right?
Oh, yeah. So I have a scrollable script here. So it's the, do you mean the infinite scrolling background or the scrollable object?
The one where you define it as being destroyed when it's going.
Oh, yeah. So in order to do that, so we've made the scrollable script here. So you would just go to, in this case, since we're instantiating all of the coins and skyscrapers and airplanes as prefabs, you actually edit the prefab itself. So I'd go to this coin prefab, I'd add component here at the bottom, and I would just add scrollable there, which is a script, and you can tell it's yours because it says script there. Just like coin here is a script and rotate script is a script. That's actually an old script that I didn't use anymore because in the coin, I just made it part of the coin itself. But this is another part of what makes the coin class, by the way, is this transform.rotate, X, Y, and Z in worlds in the different space, either relative to itself or to the world space. In this case, it chose the world space because I want it to rotate on the world's y-axis. But if you rotate an object, its own x, y, z are still exist, and so you can have something rotate about its own x, y, and z regardless of its rotation in the world. And so I want the coin to always rotate, so 5 degrees on the y-axis here. So this is another part that you could take and make it its own script, just a rotatable script, auto-rotate script, and then just make these public fields like public x, public y, public z, and then you could change those in the editor and then actually make your different objects, customize your objects without having to go into the code itself.
So you don't have to do any collision detection yourself. You just click a button and then type in the collide function.
Yeah, you don't have to do any of the collision yourself because Unity comes with a 3D physics engine. You have to tell it what to do when the collisions happen, but you don't have to actually code, you don't have to do the 3D physics engine yourself, which is a tremendous amount of work. One of the big selling points definitely for doing any 3D things in Unity. A lot of engines now have 3D engines for free. There was a time when it was less prevalent.
How would you know what you collided with?
Because there's a collider that it gets. So in the, if we're looking at the, where is it again? It's in the skyscraper, for example. So every skyscraper, when it collides with something, this on trigger enter gets passed in this collider other, and so that's going to be the object that that you collided with. And so you can get an object, you can assign a name to an object and then get its name as well in code if you needed to do that. And you can also just get, in this case, we wanted to know whether it's the helicopter or not, so we got the heli controller from it. But in our game, it's kind of a special case because there's only one type of object that has a collider that's a non-trigger, and that's the helicopter. So we can assume that this exists when we do get a collision, but otherwise we'd probably want to say get component of heli controller and then test it for equal to null. And if it's equal to null, then we want to not do something because then that'll cause us to, if we tried to call explode on a null object, that's going to be a null pointer exception, and then you're going to crash your game. So. But in this case, we're guaranteed for that not to happen because, like I said, the only collider that can collide with this that's not a trigger is the helicopter object. So, does that make sense?
Sounds like a physics problem with the explode null.
Oh, yeah. Yeah, that's all too real. In this case, though, all explode is thankfully just destroy game object and then start a particle effect. So. Any more questions as to how instantiation, prefabs, using the Unity editor, interacting with your MonoBehaviours, public variables? Yeah.
So the process is you first enter the data in the editor, and then your code, and then it runs the code to load the data, or can you also define the data in the editor?
You cannot define. So the question is, do you first create the data in the editor and then the code, and then tie them together that way? In order to get a new component, you will have to create the class first, the MonoBehavior that you want, and give it the public fields that it needs for the editor to actually read. So the editor reads your script, looks through all the public fields, and then will create the necessary GUI elements in the editor to interact with the code. But this needs to exist. All this code needs to exist. Anything that has these public variables that you want accessible in the editor needs to exist in code first, and then you have the power to use it in the editor. And then it's customizable at that point. Any more questions? All right. So that's the prefabs. So we looked at texture scrolling before, and we're going to go kind of quickly through this. But all texture scrolling was, if we recall, was I have a scrolling background class here. It's got a scroll speed. So if we wanted to, we could, since it's public, we can edit it in the editor and make it faster or slower. But we maintain a reference to our renderer. Every object has a renderer, a mesh renderer, typically for 3D objects. And the renderer has a material associated with it. Everything in Unity has a material. And so every material, a material doesn't necessarily have a texture, but in this case, our background does have a texture. And it's going to be called main text by default. That's like the main sort of texture if we want to assign a texture to see visually on a material. So material can just be a color often, but it can also be a color and also a texture. So in this case, the background is a texture. It does have a texture assigned to it. And notice that if we go to the background, and then here is where we actually create. So this is a material here. It's got a shader. So we're not going to talk too much about what shaders are. We've talked about them briefly. In Unity, they're quite a bit more. You can go quite a bit farther with them. Well, technically speaking, I guess you could go equally far with LÖVE 2D shaders and 3D shaders, at least in vertex and fragment shaders. But for all intents and purposes, we're not going to go into detail on shaders today, but they're very similar. In this case, every material has a shader in Unity in order for it to render, because anything that renders needs to be shaded in Unity. But notice that here we have a texture. So this is that main texture thing that we saw before, and then this is the bump map here. We don't have a bump map because our texture isn't bumpy. It doesn't have any like contour or like detail or anything like that. But you can just select a texture here. So I could give it that texture if I wanted to. Or like I have another couple textures here. This texture here. It doesn't matter which texture you choose, but you can choose a texture, and then that material will then it'll calculate based on the mesh how to draw that texture best to it. And you can set every material's texture offset via its set texture offset function on the x and the y axis, and that'll shift it just like we did, just like effectively accomplishing what a scrolling background needs. It'll draw it, and then it'll basically wrap around to the other side. So that's how we get the infinite scrolling texture. We just set its texture offset. We specifically call it set texture offset on the main texture, and then we pass in a vector 2, so just two numbers, offset and 0, because we don't want to touch the y-axis. So 0, and then offset is just some value that increases over time. And then time.time, recall, time since the beginning of the game has started, time.delta time, time since the last frame. And so we can just do one calculation in here and update every time, and then multiply it times scroll speed to get the scroll amount that we want here. And I've set it to 0.1 just for kind of a semi-slow effect. But in the editor, if we look at our scrolling background, which is here, and then I've made it public, so I could just easily make this like 1. And I don't know how fast that's going to be, but 10 times faster, so probably pretty fast. Yep. So it's hauling. But yeah, all it is just shifting how it maps the texture onto the 3D surface. And this 3D surface, to be clear, is just a plane. So just a plane. And notice that it doesn't get rendered from the back. So anything that's just just a polygon has one side that gets shaded and one side that does not get shaded. So if you see invisibility on one side and not invisibility on one side, that's not a bug. That's a feature. That's the texture scrolling side of things. Anybody have any questions as to how sort of that works? We won't really need it for much going forward. It's not part of the assignment, but it ties in to what we've done before. So that would be interesting to cover. Last thing we'll look at is audio. Audio is pretty easy. All you need in Unity to do audio is an audio source and an audio listener. So a source plays audio. So like if James, if you were an audio source, I'd be an audio listener, and I'm listening for audio and playing it back to the speakers when I hear any sort of source of audio in the game world. So you can have infinite audio sources, but ideally one audio listener, and it's usually whatever main camera that you're drawing with. And then sounds in Unity can be either 2D or 3D. In this case, all the sounds that I've put into this game are 2D, and that's just the spatial blend here. Notice that there's a 2D to 3D sort of slide, and so that'll calculate based on where the sound is, how it sounds in the game space, and based on how far away it is and like what side of you it is. And so the main camera has the audio source for the music, and so it just starts the music right away. So play on. Notice that we didn't have to code any of this. I just attached an audio source to the camera, and then there's a play on awake checkbox and a loop checkbox. So normally we've done like at the start of our game code, set looping to true, and then play the source. In this case, we'd have to do none of those things. This is just given to us by Unity by default.
So you put the audio on a camera?
Yep.
You could put it on anything?
You can put it on anything you want to.
The sound is relative to that object?
The sound is relative to that object, yeah. And that's audio. It's pretty simple. It's an art form when it comes to how you want to position things in your game world and how you want them to sound and whatnot. And you can get more complicated with it, but that's how you would do basic 2D, in this case, audio. But you could easily also do 3D audio just by making this set to from 0 to 1. And you can make it more or less 3D too. Like if it's not all the way to 1, it'll somewhat be 2D. So you'll hear some of it no matter what, and some of it will be 3D. And then setting it to 1, it'll be purely 3D. So if it gets far enough away, you won't hear it at all. The explosion sound as well gets triggered. And so this happens in the, I forget exactly offhand where it gets triggered. So it's in the, I believe it's in the helicopter explode function. Oh, yes. I created an object with the explosion. I created an object in the scene that has an audio source for the explosion sound. And because I made this public, I can just put it on this object. And so there's a reference to that audio source at all times. And so I trigger explosion sound.play whenever we call this explode method on the heli controller. For the reason that I didn't put it on this object because we destroy this object as soon as we get into a collision. And so I didn't want to put the sort of explosion sound audio source on this object because it would get destroyed and it would not play audio effectively as soon as we destroy it. So we have to have it somewhere else on the scene. I could have also just like made the object invisible, but I didn't. I destroyed it. And so yeah, that's this explosion sound object, which if we look at the helicopter in the heli controller, which is all the way down here, notice that it gets an explosion particles. It has a reference to an explosion particle system and an explosion sound, and we just have to click and drag the object effectively from here to pair the two of them. And then the script that this is referring to will always have a reference to those, as long as these are set to something. And notice that we also have coin total we made public, so I guess I could experiment with it. And then speed, we made this public so that you can make the helicopter faster if you wanted to or slower. And so you'll find it often useful to make a lot of these fields public just for you to experiment with. And then there's no really harm in doing so because folks aren't going to be able to actually see this in the editor when they download your game. So make as much public as you want for debugging purposes and just have fun with it. But that's audio. Audio sources produce the sound. Audio listeners listen to the sound and actually make it go through your computer speakers or whatever your default audio system is. And here's just a showcase of the two on the camera. And that's audio. So any questions as to like how the audio works at all? All right, couple last things before we close out here. So the asset store is probably one of the biggest things about Unity that kind of sells it. So oftentimes it's a lot easier just to get something, whether it's a library if you're programming or something else, get something that's implemented for you so that you don't have to implement it yourself. In this case, there's an RPG systems for rapid development, visual scripting system, sort of similar to Unreal. there's a ton of things in the asset store: models, scripts, audio, editor toolkits. A lot of cool things. A lot of it's free if you want to experiment. So like a lot of the assets that I got to mess with in this game here are free, like the coin and some of the other stuff that's bundled with it. There's a lot of really cool things and really cool systems to help you. For like 10 or 20 bucks, you can spend a little bit of money and then get like 25% of your game done like right away, and then you can actually get closer to shipping it. So it's I think it's hugely valuable to be looking at the asset store and thinking about how you can save your time that way if you're trying to actually ship a game and get to market. So definitely look through the asset store, see if there's anything that will make your life easier when it comes to developing games, because I know that I've used it several times and I rarely regret doing so. So assignment 8 is going to be pretty simple. So we looked at, for the second part, there's a bug in the game where if you die over and over again, the scroll speed never resets. So it'll just keep being faster and faster and faster and faster forever. But it's a one-line fix, and I want you guys to find where to fix it, given what we've seen today. And there's a hint here about static variables. So it'll also be detailed in the spec as well. But this is an easy part. This part's fairly easy too, because all it really is taking the kind of the same stuff we've looked at, the coin generator and coins, and then making gems that spawn instead. Or not instead, but in addition to the coins at a rarer rate. And these gems should be worth 5 coins. And so when you collide with the gems, just add 5 to the coin total. And if you collide with a coin, add 1 to the coin total. And that's basically it for assignment 8. So next time, we're going to dive into first-person games in Unity. So we'll look at some of the features that we get for free. We're going to implement kind of a simple maze-like game where you can navigate and it'll be dark and kind of scary, similar to a game called Dread Halls, which is a mobile VR game. And we'll actually test out Unity's VR and try and get a VR headset in here so people can check that out. Cool. Thanks a lot. I'll see you guys next time.